Yeah.
Give me. I'm gonna do it. Hey, sit here, man. Start it. Any of the flavors. What's up? Where's the teacher? No teacher, bro. Teacher. Not bro. You took two. Yeah, I just got two. Only two. If you need help, just ask.
I don't want to.
No, wait, what's the dog on?
I knew Graham.
Oh, really?
Oh, really now?
Would you rather
Max, are you when Christian Chen's Max?
I was in the middle of my
It'll be fun though. No, this is It's so excited. No way. Met so many good people.
Wait, that's the outside student badge. Christian has one.
Andrew was right there, bro. What if you
No, you weren't. It's not that bad. It's so warm.
It's no, but you don't have to.
Oh, you left you to try, yeah.
Alright, let's lock in.
I was like, fuck you.
I know most people.
Oh, the ferment.
Okay, hi. This is E2. This is club number 4. Focus on strategy. I want to start by talking about units. It turns out that those annoying things they come to write at the end of all of your answers are actually very useful and can help you solve lots of different problems. Does anyone know what the SI unit of mass is? What about length? Meters? What about time? What other units do you know for math that like we use every day, for example? Sure, grams, but it's just multiple of kilograms. So other units? Yeah, it's also multiple meters, but okay. Newtons is a unit of force. So these in mechanics, these are the three basic quantities: mass, length, and time. And then we have a bunch of other units which are derived from these. These include force, pressure, torque. But these are the three basic ones. Okay, maybe like pounds, tons, ounces, yeah.
Gallons.
Gallons is a unit of volume. Yeah, what about length?
Feet.
Miles.
Miles? Light years. 1 light year is the distance that light travels in 1 year. So, because light travels at 300 million meters per second, then 1 light year is like a really big distance. There's also more exotic ones, like 1 astronomical unit. 1 astronomical unit is the distance from the Earth to the Sun. So, you might see this if you're doing astronomy or something. Okay, what about time? Hour.
Days.
Okay.
Milliseconds.
Yeah, but it's also multiple seconds, so I won't write that one. Okay, but like, why millisecond is slightly different? Because like for all of the SI units, you have prefixes, right? There are powers of 10. Milliseconds, and then if you want to go smaller than that, microseconds, and then nanoseconds, those all go by powers of 10. But hour is not a power of 10, right? It's by 16. And then from these quantities of mass, length, and time, we can derive other quantities, such as force. But before we talk about force, I want to talk about velocity. What are the units of velocity?
Per second.
The reason we know that is because like maybe you're driving in a car and your speedometer reports your velocity in like miles per hour, right? So miles per hour, what is a mile? It's a unit of distance / length. And what is an hour? It's a unit of time. So these are the SI units of length, meters, and the SI units of time or seconds. Okay, and what are the units of acceleration? Okay. So then you can derive the units of force from that, right? So if we know that the units of velocity are meters per second, and we know that the units of acceleration are meters per second squared, we can write, we just need to think of any equation that has force and has other quantities which we know the units of. So we can write F equals ma. Then the units of both sides have to be the same. So the units of F must equal the units of m times the units of a. So therefore, unit of force, which is Newton, has to equal kg times meters over second squared. Agreed? Okay. And then pressure is force per unit area. So based on that, can you tell me what the unit of pressure is? So force equals pressure. Pressure equals force times area. What are units of force? What are units of area? So when I write the brackets, it means the units of this or this times area meters squared, right? So the units of pressure are kg times meters cubed over second squared. We call this 1 Pascal. This is a Pascal. What other units of pressure have you seen in your life? ATM, atmosphere.
4.
Okay, 4. There's also like PSI. Okay, but these are all measuring pressure. That's the point I want to make. Okay, now torque. On my bike handlebars, there's some text which says like 5 Newton meters. And what that means is that if you want to tighten this bolt sufficiently, suppose that like, this is the bolt. You should attach a wrench. Suppose that this is a wrench. And if this wrench has length 1 meter, then you need to apply a force of 5 newtons down on this side until it stops turning. And that's when this bolt is sufficiently tight. So torque is, that's how much torque you're applying to this bolt. This bolt needs 5 newton meters of torque to be tight enough. So the unit of torque is newtons times meters. If you use the imperial units, then you would express torque as like foot-pounds. Which makes sense, right? Because foot corresponds to meters, they're both units of length. Newtons corresponds to pounds, they're both units of force. Well, actually, we said that pounds is a unit of mass here, but the imperial units, they're very sloppy. Pound is both a unit of mass and length, of mass and force. It's like very confusing, and you won't have to think about this. I wouldn't get hung up on that. Okay, there's other derived quantities as well. I'm going to erase time. Okay, what about energy? Can anyone think of an equation that has energy? Like here we use the equation F equals ma to find what the unit of force is. Can anyone think of an equation that has energy as one of the variables so that we can solve for the unit of energy?
Squared.
Okay. What are the units of M? What about C? So this is equal to kg meters per second, meters squared over second squared. Where have you seen this before? I claim you've seen these same units before.
Torque.
It is torque. Newton meters. 1 Newton is kg meters over second squared times meters equals kg meters squared over second squared. So these are the same, but it's like, okay, even though they have the same units, they're not really the same quantity. So like we wouldn't call torque the same as energy, but they do have the same thing, so you should know that. There's another one, which is power. So if you have a light bulb, the light bulb packaging, maybe it says that it's some number, it draws some number of watts, right? Watts is the amount of energy delivered, power is equal to the amount of energy delivered per unit time. The units of energy are joules. Okay, so this is called a joule. And the units of time are seconds. So 1 watt, and this is called a watt. So a watt is joules per second. Okay, so based on what we've done, you should try the first problem. Problem 1. Given that F equals m over r squared, find the units of energy.
Is this yours?
Yeah.
Well, I'm just Adrian memorized all the questions already. He's calculating them in his head. No, I must have missed how to solve this. I don't know what you can't solve. Yes, I can, bro. Which one? Which one? Which one? Okay.
Oh my gosh. What's the calculator?
Is it torque?
Yeah.
Oh, wait, no, we just simplified.
Wait, what is the unit of meters?
What's got it? So mass times
Is it
meters
torque?
times.
Of what?
Wait, I must have missed this part.
So,
Is it theta? No, because the IQR is like, no, because the IQR is like short. That's the theta. Oh, it is the theta. That's theta. No, the IQR is just like, that's why. Yeah, IQR. Yeah, integral tau rate.
Oh my god, you got that. I was thinking how many kilometers. I just talked in my head, bro. You're not the yeah, it's pretty much.
Yes, I do,
the answer is Newton.
you actually have a peach
Is this algebra?
I definitely gotta write this down. I swear to
Like everything.
What is that? I'm assuming
Wait, I did it wrong.
Marcus right there. Why did you hurt it?
I saw him on chat. The best part is I know he's on chat. He said to the -1. No one said he said 4. I did it wrong.
I say to the negative. Just write out the steps. Wait, did you get
Oh, that's a kilogram.
Oh, wait.
Did you get it?
No, you don't get like.
It's pretty simple.
This looks actually pretty simple for you.
It is simple. I forgot.
Okay, so yours, I solved number one. We need
Nah, I
to
got
find
it.
the unit of force, and we know F equals MA, and as Kristen previously read, the unit is kg times meters per second squared. And then now we need to find g. We don't know g, but we know m times m over r squared. Big M and little m are both masses, so the top is kg times kg. And then r is the distance, so it's meters. So that's okay, so kg, if we set these, plug these back into the equation. kg squared, kg times m over s squared equals g times kg over m squared. And then if we this way g is solved, we get g equals m cubed over kg times m squared.
Why did you stay there?
Okay, now we'll talk about examples 3 and 4. So example 3 says that. I'm talking about So a mass M is hung from a string of length L, and it's just left to swing in a gravitational field. So it's just going to swing back and forth, right? It's like a pendulum clock. You can imagine that. Now the question is, what can we say about the period of oscillation? The period of oscillation is how long it takes to go to the rightmost position and then come back to the leftmost position. And we have to like come up with the expression for how long the period of oscillation is. That seems really hard. But the thing that makes it tractable is that there's not that many things it could possibly depend on. Obviously, it could depend on the mass M. It could also depend on the length of the string L. And it could also depend on gravity, because if you use a pendulum on the moon, we might not expect it to have the same period as on the Earth. So let's write out the units of these things. And also, we're trying to find the period, right? Let's call it the period T. And the units of T are seconds, because the period is how long. It's units of seconds. The units of M are kgs. The units of L are length, so meters. The units of G are meters per second squared. And we have to multiply these together in some way in order to get seconds. How would you multiply these together? Multiply/divide in order to get seconds. These 3 quantities. Because we said that it can only depend on these 3. It doesn't make sense for it to depend on anything else. Well, first of all, we know that there's no kgs here, right? So whatever we have, the kgs need to cancel out. But that means that we can't have kgs at all. This cannot be involved, since if we use this, then you would have a kg over here. So it cannot depend on the mass at all. Also, we need the meters to cancel out, because there's no meters here. So that means that has to either be L over G or G over L. So the units of L over G are meters squared over seconds squared. Oh, sorry. This is seconds squared. And the units of G over L are meters squared over seconds squared. This still has meters. We didn't cancel the meters. So wait, what? 1 over seconds squared. You can see that if I want to get seconds out, it has to be square root of L over G. Because L and G have to have the same power of L over the same power of G, the same power of G over the same power of L for M to cancel out. And then you also need the power to be exactly 1. So that's why it has to be square root of L over G. So we can say that the period is equal to square root of L over G times some constant, but this constant doesn't have any dimensions. And if you actually do this problem, it turns out that T actually equals 2 pi square root of L over G. And maybe you say, oh, but this is not a very useful result because I wasn't able to find the constant. But I claim that this is actually a very useful result. And you did it without actually thinking about the physics at all, right? You just thought about how can I combine these quantities to get useful. Why is this a useful result? Well, first of all, let's suppose that I went to the moon. And suppose that the gravity on the moon is 4 times weaker than the gravity on Earth. That means that the period of a pendulum on the moon would be twice as long as the period on the Earth, right? So I already deduced that just by using this. Even though I didn't have the constant, I could still deduce how the period scales. I also know that the period doesn't depend on the mass at all. That's another piece of information I deduced just from dimensional analysis. And finally, I also deduced that if you quadruple the length of the string, for example, the period doubles. Now, we'll do example 4 next. You can try to read the solution and I'll explain.
That's the same thing as
I made a tier list of things that make no sense. At the top of the tier list is adding two quantities of different units. It makes no sense. This is completely meaningless. This is not meaningless. So let's suppose that like if you want to add any two quantities together, they have to have the same units. If you want to say that anything equals anything else, then the two things on the two sides of your equation have to have the same units. So that means that when we add two things together, they must have the same units. And we also know that, well, you'll learn this if you take calculus, that Taylor series, the sine x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Okay, like ignore the fancy math. I don't really care. The point is that you're adding x to x cubed. So if x had any dimensions, suppose that the dimensions of x were meters. Then you would be doing meters plus meters cubed. You're adding two things together that have different units, which is nonsense. So that's why x has to have no units. So then let me ask you this. Suppose that you had a triangle, and you had some angle theta in the triangle. What are the units of theta? Okay. But we also said that the argument of, well, you can do sine theta, right? But we said that theta has to have no units. So like radians is not a real unit. Whenever I say that, so when people are talking about radian, they say the measure of this angle is this many radians, right? They just like append the word radians to their speech so that you know they're talking about an angle. If I say an angle is pi over 3 radians, what I mean is that if I draw this angle on the unit circle, then the length of the arc on the unit circle is pi over 3. Units cannot have dimensions because you can take sine of them, and the argument the sine has to be dimensionless. Okay, similarly, the arguments to sine, cosine, tangent, log, whatever function you want, they all have to be dimensionless. It also, if you take like powers, for example, I have e to the power of x as my expression, then x has to be dimensionless because it makes no sense to take to the power of a dimensional quantity. Exponents have to be dimensionless as well. Okay, should try problem 2.
You do what Tristan did. No, look at what is C? What is C?
Wait, it gives you everything. Oh! Wait, this gives you everything, right? So how much mass energy is everything? It's P. Density is
Okay, but this is the point of dimensional analysis, right? You've got some really complicated math physics, but you don't actually have to do the physics. This is why I called it doing physics without the physics.
It's just like resting for most things, bro. That's KG. Yeah.
Okay, it's 100%.
Just resting.
Okay, do you look fine? No, I think it's hard to look at it.
Would you be a theory?
Oh, really?
That's so funny. That's why I went for 35. It's super hard for me to say. The period.
I'm like Albert Einstein.
What's the unit?
Energy.
good that he's having an Eureka.
It's true. The radius is equal to. You give density.
How do we get there?
Okay, so let's start that. Acceleration. Wait.
I need it.
Yeah, and that's
Here's the
mass is the case. What is the volume? What does it look like?
You're so good. Oh my gosh, way better than.
A sphere, right? Therefore, it depends on R3. You know, sphere is entirely so this is R3. So you're given.
I trust the other people and not me. Plenty of times of like, literally did not deal with it.
Yeah, and it is kg meters per second. Do you know why? Because E is kg, M over S is the speed. So you're going to get this. Then how would you you see there has to be kg on top of E. Then with the S squared quadrant divided by S. So it's 1
Oh, so sorry. Like, any at this point.
And you wanna make
I got one and just I got it.
squared at the bottom. The only thing that's second tier is the line. Then divide by pi.
And we're given in order to get units, we're also given you round all their square in row.
I don't get it.
Yeah, so
What are the units?
Tristan, I got one in joules.
the kilogram must be divided by pi. So you have to put it here. It's only 1 kilogram. So now what we're missing is n cubed by pi. So what should we do?
Monday, next Monday.
But he already has units of n to the 3 as a volume. Actually, we have to cancel through that too.
Yeah, you want to get these every other Monday. What are you gonna do to this?
So what do you want?
Yeah, what is that?
You want n cubed on top of it, and you want n squared on top of it, or n cubed at the bottom.
No, not units are here, joules.
Radius is 5. Because first, radius is meters 5. Right? When this cancels out this, if you get meters 5 over 1, you get meters. You get this. And because there's only p.
Radius.
Yeah. Because meters. Then you can just plug in whatever numbers it gives you.
Hey, just look at it. What?
Wait, Adrian. X equals 2 count as like plug. And also
Okay, Madeline.
Remember, I won't solve it out.
That's only for the first ability.
You know what? I love it. I did something. I'm not sure what the right answer.
Wait, just
So we're doing F.
part one.
And we're doing KG for rest.
Okay.
Where you get
KG
KG
with the I did it,
KG over MQ.
Problem
Oh,
two.
yeah.
Oh, I see, because it's the, I use no.
Yeah, see, it's 1 to the fifth,
Oh, I
M to the
see.
5.
You're right.
M is
Oh, so you're canceling the
100
100.
unit of energy.
100 half to the 5.
Oh, I actually do.
Big number.
Yeah.
Oh wait, no, it's 100.
Okay, I agree.
Tristan. Because well, we also have.
I think
No, so you said we had 1 kg over M3, so wouldn't that just cancel out to 0? That would just be.
And then the unit of
Yeah,
power
he says we're
is
trying to. What matters is the F squared.
the unit of
Yeah. So
is
it's 100 squared.
seconds, and the unit of
Is
kg
where
is
kg.
actually kg squared.
We're
And then we wanna get,
Multiplying. Guys, kg over m3 times m to the 5.
we wanna get this from these units. And you can either, if you're really good, you can just look at it, I guess, and figure it out.
I guess.
But if you wanna like actually solve it, if you can't figure it out just by looking at it, you can solve a system and set the exponents to A, B, and C. So we know that the total, this equals A minus 3 and then S kg. And we know that S is B equals negative 2. And we know that C equals 1. Yeah. And then based on C, we can find that A equals 5. So for 1, we get energy equals R to the 5 times P over T squared. And then there's a constant that we don't really know. So we can just that is the answer to problem 1. And then to find problem 2, we get, oh yeah, you have to plug in the values, but I'm just not gonna. To do problem 2, we can just use E equals MC squared, and we know E, but plugging in the values, and then we know C since it's just a speed of light squared. So we can just find F equals C squared. And then if we do at number 3, we want to like find the radius of the explosion as a function of time. And we look at this equation, and then we can rewrite this equation as E over P times whatever. E times P equals R to the 5 over T squared. And then E is a constant and P is a constant. So basically, R to the 5 over T squared is a constant. So basically the function is just R of T equals T to the
Try problem 3. We'll go over the solution at 424.
what? Wait, there's always a constant that's like that what? I know it's just there's a constant.
Oh, yeah. You guys do.
Okay, did you not?
Alright, yeah.
Yes, I know how to get, yes, I know about that.
So it's R to the something times E to the right, which equals and we should have find out these somethings are. And we know that E equals and then R, what is it?
What is frequency?
So
Tristan, is frequency seconds?
Yeah. So frequency is 1 over second, right?
One?
Frequency is how many times per second.
Okay, 1 over 7. Yeah.
This guy's chatting right now.
And now we're just gonna solve the puzzle of what things are. So just looking at this, we can tell what. Okay, yeah, so
Whoa.
how did you get that? Okay, yeah.
Over M. Like not the class together. This kilogram. And then second is equal. Not one half.
Where you going?
Negative. Yeah, I was in plus
Maybe I solved it right.
You like your father?
I don't get how you I'll explain it better. Let me see. Yeah.
Well, I just.
So what does it tell you? Get the mass and
And you can solve the
So
puzzle.
mass
Okay, so this is,
just set
and
the
then so this is what it's.
kg, right? Mass.
Okay, can someone tell me what are the units of
Um,
K? We're given that F equals negative Kx. What do the units of K have to be?
X, right? X is displacement.
Really good.
What does X have to be?
That's everything.
Anyone?
I need more
X
time.
has to be its displacement, so it's a distance, right? Has to be her. Then, oh,
That's for
force is
I'm asking for what K
acceleration
units
is
of
that. You're given
F equals negative Kx, right?
Negative K.
So let's
The
divide
negative-
both sides by X.
Negatives doesn't matter, that's what you want to find out the units, okay? You're given like, you're given X is meters, right?
Meters per second squared.
So if you cancel out and
And this equals newtons over meters, right? Because if you just divide both sides by X, you're gonna get units of K over the units of F over the units of X. So it's newtons over meters. Okay. What could the frequency possibly depend on? It can depend on K.
No. Frequency is 1 to
It can depend on the mass. We said the units of K are meters per second squared. We said the units of mass are K. And we have to combine, and it can also depend on, it just depends on, it can only possibly depend on these two.
You see that this one has.
Sorry, this is not meters here.
This one and this one has, this one's the only one for X. However, it says kg, right? So therefore, how would you make it so there's no kg?
And we have to combine these to get the frequency. Maybe we call the frequency F. Frequency is how many times something occurs every second. So it has units of 1 over second. And we need to combine these to get 1
But the
over
kg is on
second.
top here.
There's no kg's here, so kg has to cancel
So
out.
K over M.
That means you have to have either k over m or m over k
1
somehow.
over 7 squared.
Yeah.
How do you make 1 over S over 1 over 7 squared?
But you can see that the only way to get the correct power is square root of k over m. So the frequency is equal to k over m times some constant.
Times what?
Times the f.
You can't really do it that way. The way to do it is just square root it.
Okay, we don't have a ton of time, so maybe we'll move on to limiting
So you
cases
get this.
so that we can.
You can only,
these,
you can only multiply
if you
X
want.
with something to be equal to S. But you can only multiply by AX or X. And none of these units are X. Right? Yeah, you're trying to get to the frequency 1 over X. But when you try to manipulate it, you can only use these. When you set it up. I think if you do more practice, you would do that. Just write everything down first. That's helpful.
Try this problem. So the idea of limiting cases is that we want to examine really special cases because those are easier to think about. So we might try, in this case, there are some parameters. There's the height of the cliff, h. So you might try h equals 0, for example, and see what each of these expressions reduces to when h equals 0. And then using that, you can eliminate some of the expressions. Okay, so the first limiting case we can check, we can check h equals 0 as well. But I want to check b equals 0. So when b equals 0, it means that, so in this setup of this problem, you're standing here and you're throwing a ball, and you want to see the maximum distance that you can throw it, right? If b equals 0, what's the maximum distance you can throw the ball?
0.
0, because you can't launch it at all, it's just gonna fall straight down. So whenever I plug b equals 0 into these, I have to obtain 0, right? What happens when you plug b equals 0 into here? Okay. What happens? This goes to 0, this goes to 0, this goes, oh, this one's also undefined. Okay, be careful about this one. You need to cancel out the b squared. B squared over g plus 2h, right? So this one's not undefined. This one, yeah. Now let's plug in h equals 0. So if it's h equals 0, you're just on the ground. Okay, these all reduce. Okay, we can eliminate this one by plugging in h equals 0, right? Because even if h equals 0, you can still throw it a finite distance. Right. So this one can't be correct. When you plug h equals 0 into this one, it says 0, but you can actually throw it. That's not this case. Okay, so now it's either this one or this one. But this one doesn't depend on the height at all. Intuitively, if you start from a higher point, you should be able to throw it further, right?
He's valid.
So we can eliminate this one as well. So you only have this one. This is the correct answer.
Next week.
Okay, now you have an opportunity to practice this. Try this. This is not that hard, I promise. It's like exactly the same thing we just did.
Almost. I'm learning. Can you try? Are you?
My memory is geometry.
Every week or like almost every week, sometimes every week. Yeah. Not for long.
It doesn't give you the right, first one doesn't give
I'm
you the
not,
right
I don't have enough hours.
How many
Oh.
I did not.
I have 10, maybe 30.
Actually, we have to.
Yeah, I only have 10. My mom.
Pi r squared.
Let's flip. Alright, bye.
Try out new languages. That's what I did, but now I have 80 unallocated pages.
We never gonna check these off.
I never checked, so it doesn't matter.
Okay, I just annotated.
She's gonna check like one day.
The one day, I didn't annotate the game tonight.
That's it.
And then she never checked again when I actually annotated it.
No, that's all we can get.
Okay, does everyone agree that the volume, that A and B are symmetrical? If I swap A and B, you should not change the volume, right? So if there's any of these where A and B are not symmetrical, then I can instantly eliminate that one. But here A and B are all symmetrical, so that doesn't help us. Okay, but what happens when A equals 0? It's a cone, right? Because one of them has 0 radius, which is like a single point. So one of them is a point. So when A equals 0, then I expect it to reduce to the volume of a cone. I've written it here. So that way we can cancel this, because this just goes to 0 when A equals 0, which is wrong. This is also wrong because it's not the volume of a cone. The volume of a cone is a 1/3. This one is pi h over 3 times b squared. This is okay when a goes to 0. This one's also okay. And this one is also okay. Now let's check a equals b. Whenever a equals b, what do we get? What states? Cylinder. So what's the volume of a cylinder? Okay. These all have 1/3, so we don't want them. Oh, sorry. This will have, if you have a equals b, then this will turn into 2/3 pi h a squared. So it still has a 2/3 in front, so it's not this one. This one will also have 2/3. This one will not. This will. This one will just have pi h over 3 times a squared. So you still have over 3, so it's wrong. This one will be pi h over 3 times 3a squared. So you get pi h a squared, which is the volume of the cone. So this has to be the right one. Try problem 8. It means like n is much larger than See you next.
Yeah, so then that's what it's gonna
Hold the more after the thing. Sorry.
Okay, can someone explain what happens when n equals m?
The first one stops.
Besides Madeline.
The first one stops.
First one stops, the one continues from being at the same.
Okay,
level.
great. What about when m is much larger than m?
They go together.
When does the speed of light?
No, they don't go together.
They both go together.
They move in the same direction.
Yeah.
That's what I guess.
What is the speed of light?
What's the speed of the small mass after they collide?
The first one stops.
Both possible.
However many factors.
No, actually it doesn't depend on the number of factors of 10. Okay, let's try to take the situation when m is much larger than m. See what happens when we plug it in here.
I got n goes backwards, the small n.
Small m bounces up.
This one goes backwards? No.
We're talking about
Okay, this one. M is much larger than m.
Maybe
Yeah,
it's
and then
the
look.
other direction. N goes
Other way.
bigger.
large m's over, right?
I see. Just say they go in this direction.
So I'm found.
For bounce off.
Will bounce off, right? Because if you plug, can you explain why it bounce off? Like what are the final velocities?
Velocity is negative, so it goes backwards. Like towards the opposite of the positive direction.
So what are the final velocities? Negative.
Yeah.
And this one's still like 0?
Wait, I don't know. No. I never said that.
Okay, what do you say?
I just know it goes backwards.
Why?
And if you get like because the velocity is positive, it's going
Then how did you plug that? So you plug it in.
Yeah, it's going this
Okay, so this is actually what happens, and you can see that by plugging in the situation, m is much larger than m into here. So let's first figure out what the velocity of the large mass is going to be. Because m is much larger than m, this denominator is way bigger than the numerator. So this goes to 0. So that's why the mass of the large block doesn't change, which makes sense, right? The large mass is like a giant brick wall. You're not going to move it at all because it has such a huge mass. However, the mass of the speed of the small one under this regime is, the m is basically negligible because it's so small compared to the large m. So we can like say that it's approximately 0 because it's so small compared to m. So then this goes to negative v. That's why the small mass reverses its velocity while the large mass stays approximately still. Okay, what about with small m? Okay, well it's basically, yeah, what happens when small m is much larger than large m?
Small m will keep proceeding with a
Yeah.
similar velocity.
Yeah, and what happens to the large?
With doubling velocity.
Yeah, that's like kind of an unexpected result, right? Well, yeah, so if you have a small one, and suppose that this one actually has a much larger mass than this one, even though their names would suggest otherwise, then this one will continue with approximately the same velocity because it didn't change that much because it has such a large mass. And the other one will start moving with velocity 2v, twice the velocity of this one. So they will not move together. That one will be moving faster than this one. Okay, and then this is another question which is similar to the types we did, where you just have to eliminate all the wrong answer choices. What's the minimum data for which is possible? So what's the goal? Like, what is the goal mass? What is the goal?
I don't hate that.
Isn't that like a cliff drop down?
No. You're trying to suppose that you can go as fast as you want. Suppose there's no speed limit. What is the minimum data?
You should not. You should like make your score like perfectly fine that everyone else. They should
What is
pay
that?
me to fail. I don't know what fail.
So if I can try that.
My future is worth more than
You understand the setup, right? So I'm asking, my question is, you supposed to throw as fast as you want. What's the minimum data for which is possible to throw a ball?
I'm cool about it.
Really fast, and your trajectory is basically a straight line, right?
Yeah.
And you need to get on top of the cliff. What's the minimum data so that you can get on top of it? Just say the height of the cliff.
We have next Monday.
How about now, the distance isn't like
We do, right?
Yes, so
We have Monday and
That's not this
Tuesday.
Monday.
No,
That is Monday.
that's
Oh, that's
But like-
next.
because we
Like
have
the
Yeah, no,
Monday
it's
after
the
Hope, we
week
don't have
after,
that one,
yeah.
but we have the one after that one. It's like the Halloween one.
I like that.
5 or 4.
I think so.
Halloween one.
Hold on, wait a minute.
Grind.
Wait a minute.
Yeah, it says it, it says it right.
You're gonna hit the wall.
I will be
Right.
grinding that.
Okay, I figured.
I
know,
have
you
never
know, I'm
grinded
slow.
that.
I figured also.
I go to the career discovery meeting.
No, you're
For what?
Career
the
discovery.
That's my main
Wait,
thing.
Anola, you're in Star?
Yeah.
Is it this one?
You were in Star?
Oh.
Star's
Spent the
what?
whole time on his
You're in
phone.
HOSA, right?
Well,
Yes, I'm in Hosa. Wait.
You signed up for the thing.
What happens when you
Stars?
plug
Is
in?
that
Stars, yeah, they sent-
They can go to Star.
Ours
You guys
is
can go to Star. Have you guys been to like the
What's
summer
that?
camp?
Okay, but like,
The summer camp?
Anyone can sign up for the basic science of
what
business.
speed do you?
But yeah, I'm gonna look for the summer
You
program.
should go. The summer camp's really good.
Are you gonna go?
Yeah, I've heard it's good. You can do junior year, right?
Yeah, the research?
Yeah, in the summer.
Yeah, junior.
So, can you try that?
Wait, what is this?
No, as well, you should do the physics summer camp.
Buddy.
Yes, you should.
Wait, Summer G, what is that though?
That is HOSA, or STARS. Well, it's STARS, but like HOSA kind of told you to sign up for that. Did you
Did I
check the
sign up
grouping?
for that?
Did you check the grouping?
I always usually check the review.
Did you sign up for the link we sent like 3 weeks ago?
Oh.
No.
I'm so excited for summer.
It has to be the first.
6 weeks away from camp.
Ah, I see.
Summer from
Also, so you see? Yeah.
Should
You're
I
doing
sign up?
your Mr. Cat.
Too late.
I don't even know.
Well, maybe it's not too late. I don't know. Try signing
Yeah, I
up.
realized that pretty easy.
Sorry?
You're such
It's a career discovery.
Okay,
What?
you guys wanna tell me which ones you eliminated?
Is it the bottom right?
I'm eliminating that.
Tristan, is it the bottom right? No.
No.
Also, it can't be this one because I
It's the
made a
second
type. I typed the same answer twice. This is the same answer.
Oh, wait, both
Okay.
of them and the.
But don't the
middle
units
top.
cancel?
What?
The units.
It can't be the top
Okay,
three.
let me ask a question. Suppose that you can throw it as fast as you want. Suppose that you are a really good thrower.
Thrower.
And you can throw it as fast as you want.
Yeah.
What trajectory does it look like?
It looks like straight up.
Line, right? Because if you throw it insanely fast, the gravity is not going to act. It will be acceleration downwards, but it won't change the velocity by a significant amount.
Okay.
Suppose that you can throw as fast as you want. What is the smallest possible theta for which it's possible to get up here?
45 degrees.
And why does anything less than 45 degrees not work?
Because it's
Because it's a-
triangle.
It'll hit the cliff, right?
Yeah.
Okay.
Right. Okay.
So if theta is 45, what's the minimum speed to get on top of here? If theta equals 45, how fast do I need to throw it?
Infinite.
Speed of light.
Infinite. You need to throw it.
Okay.
If you throw it at a slow speed, it would just do this, right? If you throw it at a faster speed, it would do this.
What?
But like, if you throw it at 45 degrees, how fast do you have to throw it in order to be able to land in this region and not hit the wall? Really fast, right?
Really fast. So a high value.
So, like, it has to be really, really fast. So let's plug theta equals 45 into all of them. What's tan 45? One?
Oh, yeah.
Okay, so it's like, the denominator is gonna go to 0, right?
Yeah.
So this would go to like a really large value. So that's okay.
Yeah, I don't have my.
But if you plug theta equals 45 into this one, you get like square root of GL over 4, right? But this is not infinite. This is like a finite value. If you throw, so that's not accurate because we said that you have to throw it really fast. This is not really, really fast.
Okay.
So we can eliminate this. Similar reasoning, you can eliminate this.
And then the top right.
So now it has to be either this one or this one.
Okay.
Oh, sorry. You can eliminate this one, yeah.
Wait, what? I eliminated that one.
You can eliminate this one because it doesn't have infinite speed. whenever theta equals 45. Whenever theta equals 45, this one goes to square root of PL over
What? Wait, but Tristan, for the middle one, isn't if it's tan equals 45, the whole thing just ends?
Yes, because it has to be really fast.
Yeah, because if this goes to 0, the denominator goes to 0, then the whole thing goes to infinity.
Oops.
Okay, so now it's either this one or this one. We need to decide, you need to decide which one it is.
I do not have mine yet.
Wait, which one is it?
That was what I thought too.
I'm trying my best.
Can we just say top left? That one seems like a nice one.
I like the top middle one.
I like the top left because that one doesn't have the cosine. Because with the cosine we get smaller.
No. This one's like one and one, so one is seven.
So it's smaller. So both of them are right. Okay, but also the middle one.
90 degrees, you're 85 degrees, you're really hard.
I got that all by myself. I didn't get any help. I'm really smart.
As it gets closer,
Sorry, I can't believe you like actually can do this by yourself.
right?
Yeah.
Can't, I got it wrong.
If it's really horizontal.
Well, I didn't know where to start. I just called that.
Yeah.
Therefore,
Middle one?
Middle one.
Wait, I don't know. I
That sounds
don't know
good.
why.
What is the middle one?
Because. Wait, no,
Makes it
and
less.
cosine
more.
zero.
Mm.
Because cosine is between zero and
Are you an
zero.
AB Ken? I thought you were. You slipped out of AB Ken?
Yeah.
No, I'm joking. I was, you know, really fun. So what was it? Was it nitric acid today? Or what was the acid today?
I think it was nitric acid, yeah. 15 milliliters.
Yeah, 15 over.
Acidic.
Like, it was crazy. And it's like, if any of you get this on your skin, tell me I need to call 911.
Okay, so we tried one limiting case. Theta equals 45 degrees, right?
You were listening.
Well, what do you guys think it is, first of all? Middle? Okay, yeah, that's right.
I think I figured out why it's middle.
If we considered one limiting case so far, I want to consider another limiting case. The limiting case I want to consider is theta equals 90 degrees. What, if you launch it straight up, how fast do you, like very close to straight up, how fast do you have to throw it to go to be able to reach this area?
Very fast.
Oh, we're gonna be able to.
You need to throw it infinitely fast, right? So what happens when you plug theta equals 90 into these two? We want to choose the answer choice, which reduces to infinity, right? Because you need to throw it infinitely fast if theta is close to 90, right? So what's tan 90? Tan 90 is sine 90 over cosine 90. So, like, oh, tan 90 is like undefined. Okay, so let's say that theta approaches 90. It's like really close to 90. So tan theta blows up, right? It's really big. So then this is going to go to 0 because the denominator blows up.
Yeah.
On the other hand, the denominator of this one also blows up, but not as quickly as this one blows up. Because as theta goes to 90, cosine of theta goes to 0. So 1 over cosine theta goes to infinity, right?
Oh wow, okay.
And this one goes to 0. But this one goes to 0 slower than this one goes to infinity, because this one is inside a square root.
Right.
So this is going to go to infinity. That's why it has to be this one. Also, even if you don't want to argue about which one goes to infinity faster, you can just eliminate all the other choices and choose this one.
Have I told you the choice?
No. Wait. Your unit units are wrong, cried the teacher. The church weighs 6 joules. What a feature. And the people inside are 4 hours wide, 8 gauss away from the creature.
They're just saying wrong units.
Hey,
The people inside are 4 hours wide.
no,
If you guys want to stay, we can do problems 4 and 5 too.
Yeah.
What
What
do
do you mean,
Why are
This
you
guy's
so-
the co-president,
I
he's the
sometimes
least
forget that
enthusiastic.
you're probably more sophomores than you're own
Josh, what?
Same thing. You should say, this is a bigger band. This is obviously more important than your band.
So how about we do 4 together, but I won't help you, so you just tell me what to write.
I don't see what math does to with your speed.
Thanks, Tristan.
First
Yeah.
the picture.
Sure, but like usually starting with a picture is a really good idea, right? But here we're doing dimensional analysis and we're not thinking about the problem.
Whoa, man.
So like we're not really thinking about the physics, so I'm not sure how much a picture would help. But sure, we can draw it.
Okay. Mr. Alvarado always tells me to draw a picture.
Yeah, like usually drawing a picture is a really good idea. Just that today we're doing physics without physics.
We're more advanced.
Or we're just trying to not think about physics. So that's why the picture is not that helpful.
How many physics courses do you think you can realistically do only doing stuff like this?
None. Like you need to combine these ideas with physical understanding, and then you'll be really good. You need to have both. Okay, well, how did I like usually generally do this type of problem?
Figure out a relationship.
Yeah.
System of equations.
No, that's only me. Unfortunately.
Everyone
else
is
is
like, look at
What are we trying to find? What are we trying to find? Speed. What are units of speed? We want to, and what can it depend on? Like that's the question I want to ask. That's the question I've asked in all of these problems. What can it depend on? What can the answer depend on? Let's make it okay. Gravity. Yeah, radius. Let's write the units. And you need to combine them to get this. So
Oh, never mind.
so now you already saw that the math doesn't matter, right?
Yeah.
Good.
Square root of G.
So what is it?
Square root of G.
Okay. So the period is proportional to square root of GR. I think it's actually 2 pi square root of GR.
Okay.
Oh, thank you.
Wait, you want to know where 2 pi comes from?
Oh.
Wait, do you know circular motion?
Kinda. I'm really bad.
That was a one time.
So we know that the period is some constant times square root of GR, right?
Yeah.
What's the centripetal force? Okay, but it's provided by gravity, right? So the centripetal force is mgr. And then in circular motion tells you that the centripetal force equals mv squared over r. That's what's the circular motion. That's the circular motion you need to know. So this equation is what we need. You can cancel the m's. So what's v? V squared equals gr squared. V equals rg. Sorry. The force is just mg, right? It's not r. Gr. So v equals root rg. it takes to go around the Earth. Wait, are we sure this result is correct?
No.
I think we made a mistake on the original one.
Wait,
Why just use this analysis? But this is definitely correct, because if you plug in the units of this is meters times meters over second squared, you get meters per second for velocity, which is the correct units for velocity. Okay, the amount of time it takes to go around the Earth is 2 pi r divided by the velocity, right? The circumference divided by the speed.
I'm sorry, I'm looking for something. I'm looking for notes.
People aren't even gonna go
Hello?
So I think we should have gotten square root of r over g for the previous one, and then the constant is 2 pi.
Oh, wow.
Okay, last one, question 5.
That's not, that's for that.
You wanna explain?
Oh, you want me to wait a bit?
Yeah, wait a bit.
Do you know how to do long division?
No.
I do not know how to do all of it.
You don't?
I probably figured it out.
No, that's a very common thing.
Like, I'm gonna have to figure out how to do it for AMC.
For what?
Yeah, the math competition. You don't get a calculator.
Long division, like
Yeah.
50 divided by 5.
Yeah.
Yeah.
Or if I ask because that's like the two right now. Right? The one that Henry does?
Oh, you probably should.
Yeah, because he's such a good teacher.
He is? He's such a bad teacher.
She's hating. Just don't listen to her.
You know,
He's such a bad teacher, you tried once.
every great person in the world has haters.
Yeah.
Wait, where is Henry, bro?
He's at the middle school. Freaking Diddy.
Um,
Am I right, Adrian?
Yeah, you're right.
What?
This guy was doing the tutoring and he spent half the time playing Clash Royale with one of the kids. Worst tutor of all time.
You?
And the other time he did, he just
Adrian?
Don't look at me.
Yo, who else is gonna look at it? It was only you. I talked to Ryan. He almost kicked you, Andrew, and Kamar out from tutor.
It's my fault.
Why are you guys looking at it?
But I asked because there's been a few times where
Okay.
the tutor has been like,
What? You just find
No.
energy and then you find their
Let's do
mass
something
density,
else.
and then you find- You just like derive what the power is.
What's your answer?
Alright, well, I'm gonna start explaining because you're gonna slow. So, energy is equal to mc squared. So it's just k. Y'all agree with this, right? So, what can this possibly depend on? It tells you it's a solid ball, it's a mass density, and a radius is e, and it tells you it's a gravitational. So it can depend on.
Gravity?
It can depend on the gravitational constant. It can obviously depend on mass. So let's just say this is equal to, say this is mass, and it can depend on the radius, right?
That's it. Can you say something?
Okay, for gravitational constant, I think someone did this earlier. It was just, I think G was equal to, oh, there we go. It's equal to, I don't know. Oh yeah, M3 over. Okay, so this is equal, radius is obviously equal to meters, right? So how would I do this? This is second square. That second square matches up, and these are pretty easy to manipulate. So therefore, pretty obviously, it's going to be equal to G m squared over R.
Never teach again. Yeah, leave it the truth.
Yo,
Can
that
you
was
like, be a
nice.
little bit more detailed as to how you
It's like if you look at it and then just by looking at it, obviously it's
Alright,
that.
so my fault. Let me read this. E is equal to kg and
You could solve a system like I did.
No.
Actually, ChatGPT did solve the system. On one of them.
Exactly.
On the one that you got wrong, ChatGPT solved the system. That's how
That
it
I,
goes.
that's really,
That just means you solved the system.
yeah, I heard a source.
So let's
These
say.
people are peer pressuring me to not solve this.
It's what the big G said.
How do I solve systems? So I think it's literally just.
This is the guy tutoring over. Seriously,
You
this guy,
see?
this guy tutoring
How
like
you
So
solve
then 3a because these are the exponents. No, I know how to solve this. This is easy. So this. You stop laughing so much. I didn't even say anything. M, there's one exponent here, therefore you could just do. Let's say this is equal to A, this is equal to B, this is equal to C. Therefore you get this plus C has to equal this meters up here, which is equal to 2. Negative B minus C equals 1. There. So from this, C must equal to 1. Agree? Then B. Oh, actually, let's do this one first. I don't think A is equal to 1/3.
Wait, M should be.
Should we do something else?
I don't.
A as M and then B is Q.
Wait, A equals 1/3 is not automatically wrong, right? I wasn't checking you, so there could be a mistake, but like, you shouldn't just instantly reject it because A equals 1/3.
No, I should reject it.
Okay.
No! Systems always work.
Okay, because it has to be S squared, G has to be on the top, and it's only G on the bottom, so it has to be M squared on the top.
Very cool.
Man, after this, I can show you a question where solving a system does not.
Therefore, it has
Oh,
to be G
yeah.
times M squared
I
over
mentioned
R.
that.
Don't exist.
All the teachers tell me that math, you should use math twice, but I still use math. I don't know, like all of the teachers tell me that.
All the teachers.
All of them. I can't. Like when I.
I thought you guys were doing math points.
Yeah, and you said you shouldn't do it.
Oh. Oops. So what are you gonna use besides math points?
Nothing.
So you just like leave it blank?
Yeah, totally.
Yeah. But where did you Ada.
How'd you?
Ada.
You square it. You square it.
Oh, that's where I messed up. Never mind. So A is equal to 1, that's my fault. Because it's negative A is equal to negative 2. Then therefore, C must equal to negative 1, and this B must equal to 2. So therefore, it must be G over whatever C is, R, M squared. As I said before. Y'all agree with that?
That was a good one.
Okay, that's
I
like,
did not know what was going on.
let's say that's some easy steps. Oh.
No, you went wrong.
If I didn't do the system, I thought it was pretty obvious.
I know it was, I know it too, but just like, if you don't know how to do it, you should do it. But apparently Tristan says you can.
Then, what am I trying to find here?
That there's
Oh, maybe the system.
I like being very annoying and using a system works 99% of the time. No, I just wanted to show you a question where
Oh my
dimensional
God, just be
analysis
quiet.
doesn't work. Okay.
So, mass is equal to mass over volume times volume, right? Therefore, it's equal to density times volume, right? So the volume of a sphere is. Okay, well, it's. I guess.
4 over 3 pi.
So therefore, if you just substitute this and you get mass is directly related to the density times r cubed. Because these are both constants.
Obviously.
So it's related to. Then if you plug this back in, you get E will be related, okay. It'll be related to G P squared R to the 6 over R. And one of the R's cancel out. So what's changing in this question? The only thing that's changing is R goes to 2R, right? Everything else stays constant.
Yeah.
So what happens when you plug in 2R? You get 32E. Pretty light.
Yo, just stop. Back it up.
Does Henry know that you put that in
He
Henry
doesn't.
Lewis?
Oh, I don't even feel like that was a
Oh,
hard
no.
diss.
You should show him.
You just go ahead.
Well, because that could
Or
be
you
a
can
good
send
thing.
him.
That could be a
No,
good
I'm
thing.
okay.
Like, you could be like, his brain works in such crazy ways. He's just so smart. Or you could be like,
I mean, I just sent him the presentation, so he saw it.
what are the chances he looked at him?
0.
0.
I don't look